Okay, so last thing we're going to talk about in these neuroanatomy video lectures is the neuromuscular junction. All right. The neuromuscular junction. Okay? This is often abbreviated to NMJ, neuromuscular junction. So, what is the neuromuscular junction? It is the chemical synapse between a motor neuron, or multipolar neuron, and a muscle fiber, okay? So this is the chemical, oops, my S's look very weird. Chemical synapse between a neuron and a muscle fiber. Okay? So, let's draw this. All right, so we have, let's start with our neuron. So, we're going to be zooming in really close to the neuron, and we're going to be looking at the very end of the axon. And not only is it the end of the axon, but, okay, so let's say that we've got our multipolar motor cell. Okay, and it's going to come and its axon is going to terminate right next to a muscle fiber, okay? All right. All right. So the thing we are zooming in on is right here, this very tip. And actually, if you get really up close, the very ends of the axon terminals, they get a little fatter, and they're called the terminal bouton. So this is what we are zooming in on. Okay, so over here, we've got our neuron. We've got a terminal bouton. From our neuron, okay? And in the case of a cell that is connecting to a muscle, do you remember Schwann cells? Schwann cells are the glia that create the myelin sheaths, usually along the axon, but at the neuromuscular junction, there are Schwann cells all the way to the end, right here, on the terminal bouton, okay? So we've got a little Schwann cell here. So this is our neuron, and what we're actually looking at is, this here is the terminal bouton. That's what it's called. This is a Schwann cell. Okay. And because at the neuromuscular junction, there's a lot of movements. We're moving all the time. We're activating our muscles a lot. So it requires a lot of energy. So usually the terminal bouton has one organelle in it, not just one, but it has a type of organelle in it. Normally all the organelles are in the soma, but in this case, in the terminal bouton, we also have mitochondria, which you may have heard of. They create energy for the cell, okay? So this is our mitochondria. Mitochondria. They create energy for the cell. Okay, so when an action potential arrives, so step one is an action potential. What happened at the synapse in general? Remember when we talked about the synapse? What happens when an action potential first arrives? What does it do? Okay, so it triggers some voltage-gated calcium gates to open. Calcium ion channels. So we have, just like in a regular synapse, we have here step 2, which is voltage-gated calcium channels open. Okay? And this allows what? This allows lots of calcium to enter the terminal bouton. Okay? So these ions are going to flood in. So the ions are going to all flood in, and what are they going to do? They're going to activate a vesicle. Okay, so here is our vesicle with some chemical inside of it. Which chemical do we think it's going to be? Which neurotransmitter is used for activating muscles? Acetylcholine, okay? All right, so I'm going to say that the orange dots, this is acetylcholine, okay? So, the calcium ions, we got lots of them here. They are going to activate this vesicle, and what is going to happen? The vesicle is going to move towards the cell membrane, and it's going to fuse with the cell membrane in order to release acetylcholine into the synapse. Oh, and we did not even draw the muscle fiber underneath. What does it look like? Well, this muscle fiber has a bunch of folds right at the neuromuscular junction, okay? And the reason why is, if it was just flat, so think about it this way, we are going to have a bunch of receptors in the membrane, okay? And I'm going to use a different color to show that they are different. So you can only pack so many proteins onto the cell membrane. by having these folds, this means there are more receptors, more proteins available to pick up acetylcholine and activate the muscle, okay? So it's a way of increasing the number of receptors in a very small space without taking up more space, okay? Actually, it would probably be up here. All right, and so on and so forth. Just imagine every possible surface is just packed. It's packed with proteins that are waiting to receive acetylcholine. All right? Okay, so this was step number 3. So first we had the action potential. Then second, we had the voltage-gated calcium ion channels open. Then number 3, the vesicle moves towards the cell membrane of the neuron and releases acetylcholine into the neuromuscular junction. Okay? Then, on this side, these receptors are called nicotinic acetylcholine receptors, okay? So this is called nicotinic acetylcholine receptors, okay? This means these proteins are activated by acetylcholine, okay? And what they do is, so these are ionotropic receptors, which means what? That means that the acetylcholine acts as a key, okay? So if it comes down here, it's going to bind to these proteins, and it will open up an ion pore, an ion channel, a tunnel through which sodium will come in and potassium will go out, okay? So ionotropic, and it lets sodium in and potassium out. So this is a receptor that allows 2 different kinds of ions to pass through, okay? Sodium and potassium. All right, so that's step number 4. Actually, I'll do this. Step 1, step 2, step 3, then step 4, we get an influx of sodium. So sodium in, potassium out, okay? So you get, let's draw it over here. So if we've got stuff binding, so sodium is going to come in and potassium is going to go out. Okay. All right, so what this can do is, so does this look familiar? Sodium coming in, potassium going out. That looks an awful lot like an action potential, right? So muscles can also depolarize. So this muscle fiber that is being activated right now, it can depolarize, and that causes a bunch of different events, bunch of different chemical reactions that eventually results in a muscle contraction, okay? So eventually, if this happens a lot, all of the muscle fibers get activated together and you lift your arm, okay? All right, so that is our final neuroanatomy diagram. The neuromuscular junction it is a special synapse between a neuron and a muscle fiber, all right?